There we go. So looking at a segment or a line segment, okay, its description, just like we had descriptions with our points, our lines, and our planes, it is part of a line. Okay, so it is just part of a line. It has two endpoints. Okay, so with a line segment, you have two endpoints. Now, to name this, we name a line segment with the two endpoints and a line above it. Okay, so an example of that would be our line segment here, x, y. So we have our two endpoints, x and y. You would use those two endpoints, and then instead of the arrows at the end with that line above, you don't include the arrows because it is just a line segment. Okay, questions on that? Next, we have the measure of a segment. Okay, so that is just the length. It's the length of that segment. So to name that, we use units. Okay, such as centimeters, meters, feet, inches. Okay, so we use these different labels here to indicate measure. So an example of that would be xy is equal to 4 centimeters. Now notice there isn't a segment bar above the x and the y. When you're talking about segment measure, you don't include that segment bar. Okay, that's the difference between the two. This one talks about segment measure, so it actually has a measurement associated with it. This one is just talking about the segment in general. It's not talking about its measure. Okay? That's usually a confusing topic for most. Okay, then next we're going to move into congruent segments. Okay? Congruent segments have the same measure. They are equal to each other. Okay, so if something is congruent, they are equal. The symbol for congruent is this equal sign with a squiggle above it. It's the only way I can describe it. Okay, so that is your congruent symbol. It looks like this when it's on my sheet of paper. Okay, so that is segment AB is congruent to segment CD. Okay, and you can see that in this example over here. We have segment AB at 1.7 centimeters and segment CD also at 1.7 centimeters. So you can say those segments are congruent. Now another way to tell they're congruent is this dash in our line right here. So if you see that, that means those two segments are congruent to each other if you weren't given their measures. Okay, so if you just saw that dash in that line, they are congruent or equal. Now if I had a second segment over here, okay, and it had two dashes in it, that segment is not congruent to this one. Okay, you have to have the same number of dashes within the segment for them to be congruent. Does that make sense? Yeah? All right. Any questions so far? Again, we're just looking at segment measure. All right, we're going to get into some examples then. So for number 1, we want to find the length of each segment. So letter A, we have segment CD. Now our ruler here is in inches, so that means I have to label my answer in inches. So always look for that label. Now each of these go up by 1, 2, 3, 4. So I'm going up by 1/4 each time. So I know I hit 1. I add the next section here. So that means I'm at 1 and 1/4 inches. I know you know how to use a ruler, but it's fine. Questions on A? All right, then B, again, we're in inches. Okay, I'm going to count how many dashes I have between 0 and 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That means each of those pieces are 1/16. Okay, so I know I at least hit 1 right here to get to point D. But then I have 1, 2, 3, 4 of those 16ths. Okay, so 4/16 is the same as what? 1/4. So I know my segment, again, is 1 1/4 inches. Okay, then letter C, again, finding our length. This time, I'm in centimeters. Okay, centimeters go up by 1/10 each time. Okay, so I know I at least hit 3 right here, and I have to see where this B point is, so it's about this one right there. So I know I get to 5, then 6, then 7. Okay, so I can either write this as 3 7/10 as a fraction, or I can write this as 3.7 because that's 7/10 as a decimal. Now if you wanted to get really crazy, you could write it in millimeters as well. Okay, so if I were to write this in millimeters, it would be 37 millimeters. Okay, questions on our measuring of line segments? I know I went through kind of fast, but figured you guys knew how to use a ruler. All right, next we're going to look at betweenness of points. Okay, so point N is between and collinear. I know you don't have enough room. Okay, it's between and collinear with points A and B. So point N is right here in our picture. It's between A and B. Okay, so just anywhere between the two. It doesn't have to be right in the center. And it's collinear, meaning it lies in the same line. Now points R and P are not between A and B. Okay, so R is off to the side here. Segment AB is right here. So R is not between those two. And P is not even collinear with A and B, so it's not between them. So it has to be collinear and it has to be in the center of those 2 points to be between. All right, so point M is between points P and Q. Okay, so again on to the right here, M is between P and Q, so it lies in that same line. If and only if, it's important, P, Q, and M are collinear. Okay, so they all have to lie in that same line. And then we can say PM plus MQ is equal to PQ. So I can take this segment right here, PM. I can add it to this segment, MQ, to get the total segment of PQ. Okay, that's the segment addition property, and we'll get into that later with proofs. But that is the segment addition property, and it is something you should know. You don't have to know that it's the segment addition property yet, though. So we're going to use that to find different segment lengths. So in number 2, we want to find this segment E to G. Okay, so that entire segment there. We're given EF and FG are 2 3/4 inches. So I can just use my segment addition. We would take EF plus FG to get EG. Okay, and then all I'd have to do is plug in those numbers. So EF is 2 3/4. FG is 2 3/4. All I'd have to do is add those together to get EG. Now if you wanted, you could put it into a decimal, just be 2.75. That's fine. But when you do add them together, you should get 5 5.1/2 inches. Or 5.5 inches. I'm fine with the decimal if you want to put it in decimal form. Questions on how I did number 2? No? If you haven't already, do number 3. Find JL. All right, so again, we're just using this segment addition. So I have JK and KL. To get JL, I just need to add the 2 together. So 8.4 plus 3.9. Okay, that is 12.3 centimeters. Okay, so you should have gotten 12.3 centimeters for JL. Questions on that? Okay, then number 4 is a little bit different. We're still using this segment addition. We're just using it a different way. So we want to find AB. So that's this segment right here. What do I have to do differently to find that segment? Subtract. So I can take my entire length of AC. I can subtract one of the smaller segments that I know, that's BC, and that will give me AB. Okay, so taking AC, that's 13.2 meters. Subtract BC is 5.8 meters. That will give me AB is 7.4 meters. Okay, so you're still using that same segment addition property. You're just using it in a different way now. Okay, questions? It's okay to ask questions. All right, so 5 and 6 are a little bit different. You will have to set up an expression and solve for a variable. Okay, so number 5, we want to find, I'm going to use my highlighter. You want to find A and XY. You have to find both. Okay, so make sure you're reading your directions. You should have 2 answers for this one. Find A and XY if Y is between X and Z. If XY is equal to 3A, XZ is equal to 5A minus 4, and YZ is equal to 14. So when you do a problem like this, you need to draw the picture and label it. So I know I'm dealing with segments, so I'm going to need a segment. It doesn't have to be slanted. It can be just horizontal, however you want to draw it. Now, in my directions here, it gave me Y is between X and Z. So that means one of your points between those 2 endpoints has to be Y. And then your endpoints have to be X and Z. From here, I can label each of my segments. So I'm given XY is 3A. So I'll label XY as 3A. I'm also given XZ is 5A minus 4. Now that's the entire segment. So however you need to write it to see that it's the entire segment is fine. I usually draw in a second segment below it to label that is 5a minus 4. So I know the entire segment there is 5a minus 4. Okay, then I'm also given that YZ is 14. Okay, so YZ is another smaller segment there. And I'll label that 14. So just like before on the front, we're using this segment addition. Okay, so I can add together my two smaller segments to get my larger. So I'll add together XY plus YZ to get XZ. And I can just plug in what I know about each of those pieces then. I know XY is 3A. I know YZ is 14. And I know XZ is 5A minus 4. Okay, from here I just need to solve for A. Okay, so I can subtract 3A. So I end up with 14 is equal to 2A minus 4. Add 4 to both sides of my equation. So I have 18 is equal to 2A. Divide by 2. And A will equal 9. Okay, so that's one part that I needed to find. The other part was XY. So I need to find the length of XY. Well, XY is this 3A piece. Well, I just found what A was. So I can plug in 9 for A. So I have 3 times 9. That's 27. So XY would be equal to 27. Questions? We're good? Make sense how I set it up? How I solved it? All right, I want you guys to do number 6. Did you finish it? All right, most people are finishing up this problem. So going through this here, again, you're finding two different things. You're finding x and BC. Okay, this time you're given B is between A and C. So again, I want to draw in a segment. A and C are my endpoints. B is somewhere between. Okay, again, it doesn't have to be exactly in the middle, just somewhere between the two. We're also given AC, so that's the entire segment, is 4x minus 12. AB is just x, and BC is 2x plus 3. Okay, so just like before, I can take my two smaller pieces and add them together. So I have x plus 2x plus 3. Set that equal to the entire segment of 4x minus 12. I can combine like terms on this side. So instead of an x and a 2x, I have 3x plus 3 equals 4x minus 12. From here, I'm just going to solve for x, so I'm subtracting 3x. Add 12. And I end up with x equal to 15. Okay, so my x value is 15. Then I also have to find BC. So BC is right here. I already found what x was, so I can plug in 15 for x. So I have 2 times 15 plus 3. Okay, that's 30 plus 3 is 33. Questions on how I did that? Most of you looked like you were doing it correctly as I walked around. All right, then moving on here. Numbers 7 and 8 have to do with congruent segments. So again, congruent segments are segments that are equal to each other. They have the same length. So looking at our picture here, it's asking for what the congruent segments are. So I'm going to look for these dashes within my segments. Okay, so both AB and AG have that single dash in them. So I can say segment AB is congruent to segment AG. Okay, and I am going to use that congruent symbol so you know what I'm talking about. So segment AB is congruent to segment AG. Okay, what's another one? Look for the similar dashes. Yep, go ahead.
BC and GF.
BC and GF. Okay, so BC is congruent to GF. Okay, what's the last one? I know you know what it is. CD and FE. Okay, so that's just naming those segments that are congruent. Again, they have to have that same measure. All right, number 8. In the graph, suppose a segment was drawn along the top of each bar. Which states would have the segments that are congruent? So look at your graph. Which two states are congruent? Anybody? Which two states are congruent? South Carolina and Nebraska. Okay, so those two states are congruent because they both have the same number of state parks. Okay, so that's why they would be congruent. They both have the same number of state